this video, we will talk about the history of atomic theory. So let's see the objectives of this lesson. We will understand the ancient metallurgy role in the development of atomic theory, and we will also see the early philosophical contribution to the atomic theory, the Greek early philosophical contribution. Then we will see and we will recognize the influence of Arab scholars to the atomic theory and to chemistry in general, and then we will see the evolution of atomic theory. So let's go to the topic. Introduction. Living and non-living things in this world, they are made of building blocks. Building blocks. And these building blocks are chemicals. So chemistry is trying to study the structure and the structure and properties of the matter and how chemical change happens. Chemistry helps us to understand the processes like burning, weathering. These are natural processes. Chemistry is trying to figure out how these processes happen and why they happen. Chemistry also try to understand and know the chemical processes in living organisms also, not only in natural processes, also in living organisms. Okay, how is chemistry developed? Very long time ago, during the prehistoric people, those people in all time, they tried to master and control the use of fire. And this is how chemistry started. Fire. And they control fire to cook, to generate heat, and also other different purposes. The human manipulated material in sophisticated ways. For example, to make tools and also weapons. Then later, they created materials like soap and medicines. Although they were very primitive, but this is how chemistry started. Making these products needed a deep knowledge to make soap, to make medicines and other things. They needed knowledge of the raw materials, the chemicals that make up the raw materials. And they needed skills, techniques to refine and purify those materials or chemicals. So let's see the metallurgic ancient chemistry. We see here in this picture an ornament from the Bronze Age, and this was 3000 BCE, before the Common Era. smelting of copper and tin ores. And ores are natural existing rocks that contain minerals, metals. So copper and tin together, they make an alloy, which is called the bronze. And the first use of bronze was called the Bronze Age. They use the smelting process, and the smelting process is use of carbon from charcoal, which reacts with oxygen in the ore because the ore contains oxygen, and it will leave the metal, tin and copper. And this was the bronze, which is the alloy of copper and tin. This bronze is hard, resistant to corrosion, and also was low in the melting point. Okay. Then comes the Iron Age. This was 1800 before the Common Era, BCE. Here, iron replaced the bronze. The reason is because of its hardness and its abundantness. It was found more than bronze, so they use iron. Another thing is uh, it is this use of iron required high temperature and especially designed furnace. So in the 6th century before the Common Era, 600 before the Common Era, there were many techniques, widespread techniques in Greece and also in the Middle East. So there were many artifacts. Okay, example, swords, spearheads. Like for example, archaeology has found for us these tools from the Kirkburn in England. This was 300 to 200 BCE. This picture shows a sword and a spearhead from Kirkburn in England. So philosophical theories on matter. Okay, this was 400 BCE. Leucippus and Democritus. These were two Greek philosophers who proposed that concept of atoms as the smallest indivisible units of matter. The Greeks were discussing that if we study the building block of everything in this world, we will reach to very small particles. We call them atomos in Greek, and they are indivisible. The picture shows Leucippus and Democritus from 400 BCE. Then two other scientists, Empedocles and Aristotle. This was 350 BCE. They said that matter composed of four elements, and these are fire, air, earth, and water. So the elements associated with different properties, these four elements, air, fire, earth, and water. Aristotle views about metals could transform by the changing in their qualities. Okay. Advances in chemistry post the Roman Empire. This was the Islamic Golden Age, 7th to 8th centuries. Okay. And this is the emergence of Arabic scholars. Why this emergence of Arabic scholars took place? Because this is due to the translation of ancient Egypt and Greece philosophical studies into Arabic. They translated them, and this led to significant contribution in astronomy, mathematics. For instance, in mathematics, we have Al-Khwarizmi, who has developed the algorithm in maths. We have geography and chemistry, Jabir ibn Hayyan. Okay, let's see Jabir ibn Hayyan, the life and influence. He was born in Jabir ibn Hayyan was born in Tus in Iran and lived until the 803 CE. He was a court alchemist under a ruler called Harun al-Rashid. He integrated the practical alchemy with the studies in mathematics, science, and Greek philosophy. So the Arab alchemy contribution, the theoretical foundations. So influenced by Aristotle theory, the Arab alchemists, they were influenced by the Aristotle theory of elements, the four elements, fire, air, yeah, fire, air, and water. So he believed that metals, including gold, were composed of mercury and sulfur in ideal proportions. One of the most contribution is this tool here. It was developed by Jabir ibn Hayyan and it is called alembic, which is derived from Arabic word al-imbigh. So laboratory innovation, the techniques and apparatus, they develop techniques like crystallization, sublimation, calcination, and they identified important chemicals like hydrochloric acid. Jabir ibn Hayyan, he has a credit to discovery of sulfuric acid, nitric acid, sodium and potassium salts. Jabir ibn Hayyan invented this alembic apparatus and it is used for distillation. This alembic, which is in Arabic called al-imbir. Okay, practical and theoretical integration. This link theoretical alchemy with practical laboratory in chemistry. And this is a very big credit of Jabir ibn Hayyan. He used the theory of the Greek philosophical thoughts and he used practical laboratory chemistry. The Arab, there are many words that are derived from Arabic, like alcohol, which is derived from Arabic word which is alcohol, elixir, which is elixir, and this was they were trying to find medicine which can cure every disease, and this was called elixir. Alembic, the apparatus that Jaber has developed, is derived from alembic. Even the word chemistry is derived from the Arabic alchemia. Chemistry in the High Middle Age, civilization and agricultures grew across the Western Europe, and then translation of Greek and Arabic texts into Latin, including the ideas of various or in various fields, including chemistry. This had led to the Middle Ages development. So alchemy in medieval Europe, diverse interpretation, okay, embraced as a spiritual quest, practical science, and magical studies. This is why alchemy has developed in the Europe medieval age. Skepticism existed. Some view it as heaven for frauds. Notable figures during this age and events. We have this tale, which was written by Geoffrey Chaucer. You can read this tale. It is called the Canterbury Tale. It talks about the alchemy, okay, the canon's human tale, and it talk about an alchemy who was trying to change uh, metals, other metals into gold. Nicholas Flamel in the 13th century, 1330 to 1418, he thought the philosopher's stone, they call it philosopher's stone, to burn or to turn lead into gold, change lead into gold. This was in the tale also. His legacy included famous Paris resistance and fictional mentions. Revolution in chemistry, and this was credited to the father of chemistry, Anton Lavoisier, and this was in the 17th century. Okay. Alchemy and practical chemistry coexisted and often overlapped, okay, together. So the key figures here, Robert Boyle and Sir Isaac Newton. So then Anton Lavoisier in the 17th century, 1743 to 1794. Okay. He has made many scientific contributions. He revolutionized chemistry by explaining the processes scientifically and developed the modern research methods. So he disproved the phlogiston theory, okay, and I identified oxygen as a key component of combustion. Chemical nomenclature methods do nomenclature introduce systematic naming and classification of chemicals and replaced ambiguous named with fixed composition base names. Like for example, lead nitrate replaced Niter of Saturn. Okay, the planet, they were using this kind of naming, so they used lead nitrate instead in this 1787 age. Impact of nomenclature, adoption and criticism. This gained widespread support despite initial criticism, established a modern language for chemistry which we use now, influencing both Europe and United States. Okay. The phlogiston theory versus the oxygen theory. Basically, the phlogiston theory, prevailing the theory suggesting that substance contained a substance called phlogiston, and that was released during the combustion. Okay. For instance, lead nitrate or mercury. Okay, mercury contains phlogiston. When we burn mercury, this phlogiston uh, substance is released. But Lavoisier experiment has disproved this phlogiston theory, and he confirmed that air is composed of multiple gases, different gases. He demonstrated that combustion involves oxygen and not phlogiston, and the matter is conserved. He used mercury, he burned mercury, and then mercury oxide was produced. Marie Lavoisier, the wife of Lavoisier, supported and contributed to his experiment. She recorded the experiment, transcribed note, and created schematic drawing figures. She was important partner in Lavoisier scientific achievements and public agreements. Engagement. Okay. Advances in chemical theory. This was the early 19th century. Anton Lavoisier influenced chemistry. Precision in terminology. He used very specific and precise terms, advocated for precise definition of terms like elements, compound, mixtures, and predicted some substance thought to be indivisible might be compounds. So Anton Lavoisier, that's why he's considered as the father of chemistry. Okay. Claude Louis Berthold contributed to Lavoisier nomenclature and researched various chemical applications. He discovered the reversible reactions, Claude, and during his observation of Naraton formation in Egypt, okay, noted that the conditions such as heat and pressure influence the reaction outcomes and product composition. There was a debate between Prost and Berthollet. Joseph Prost in the 17th century proposed the law of definite proportion. He found that chemical compounds have fixed composition by mass, and this is called the law of definite proportion. Example, copper carbonate decomposes. This picture shows the decomposition of copper carbonate in a building. Impact of their work. Berthollet's findings reveal that some compounds have variable composition and observed that chemical reaction can be influenced by external conditions. Uh, Prost's position. He emphasized that compounds have constant composition, correctly identified that Berthollet's reaction mixtures were not pure compounds but mixtures with varying composition. Resolution and legacy. We will talk about this topic in the next video. Thank you. See you in the next video. Please subscribe my channel, like and share.